Welcome back to part 2 of closing the gap between yield potential and achieved yield, a focus on peanut variety. In this section, we'll answer the question that I posed in part 1, can we close that yield gap? And we'll do that by looking at the factors that cause the yield gap. First, let me answer the question that I posed in part 1, can we close the yield gap? I believe the answer to that question is yes. But in order to do it, we need to understand the factors that reduce yield potential in a farm setting. We'll first look at the factors and their interconnectedness because they are all interconnected with one another. We'll look at the basic agronomics and talk about rotation, which is the key to almost everything. Proper soil fertility is also a basic agronomic of getting a good plant stand and water, irrigation, or sufficient rainfall. Then we'll look at the variety and how to manage each from a disease standpoint, vine growth, maturity, and other aspects of that variety's particular set of strengths and weaknesses that we need to know to achieve its maximum yield. So maximum economic yield cannot be achieved without these 12 factors, at least these 12, but these are 12 major factors. And I've highlighted the agronomic ones here, and rotation is really number 1 on the list because it is really the key to many of the things listed below. But obviously proper soil fertility, soils and tillage are important, the planting date's important, and interacts with disease susceptibility and reaction, as well as plant stand and water. And of course, some of these things we don't have a lot of control over. If it's non-irrigated, we're relying on the weather to provide the water that we need. If it's irrigated, then it is under our control to some extent. But all of these are interconnected and mostly under our control, except for weather and water. And obviously with that many factors, 12 factors, it's really impossible to go through all the potential interactions among those. But I want to point out one really important interaction. That's the interaction between crop rotation, as we see here, and reaction to leaf spot and white mold. This data comes from the Peanut RX. The website can be found here, and you can do this for yourself. You can go in and modify each of these characteristics that you see here. Each of these factors can be modified, and you can see the impact of modifying those production factors on the disease risk that you see here along the bottom for spotted wilt, for leaf spot, and for white mold. Green means low risk, yellow means moderate risk, and red means high risk. I've entered a value of 1 for crop rotation. That means planting peanut every year in the same field year after year. And I wanted to look at the impact of that on leaf spot here and white mold here. And we see that regardless of the variety that we plant, that's what's listed here, or the time of year that we plant it, we can only achieve a moderate or high risk of disease with only a single year of rotation. So in the previous slide, we were looking at a 1-year rotation. Now we're looking at 2 years, every other year peanut. And what we want to point out is that in leaf spot risk here, we saw that there were only a few moderate risk categories where we could have a moderate risk of disease based on the variety and the planting date. But now there's almost half the entire area is moderate risk for leaf spot because we added 1 year of rotation here. Same with white mold. If you remember from white mold, with 1 year of rotation, the entire block was red. In the previous example, when there was only 1 year of rotation, now we have several areas where, depending on the variety and the planting date here, we can get into a moderate risk category. And now if you look at the last scenario where we're rotating 3 or more, and that means at least 2 years of another non-host crop between your peanut crops, we see that the leaf spot risk and the white mold risk is mostly moderate, not high. So that's the impact of just rotation on these 2 fungal diseases, depending on the variety that we plant and depending on when we plant it, and having at least a 3-year rotation, meaning 2 years out of peanut, the risk of these diseases drops significantly when we're able to do that. And that's an example of the interaction between rotation and disease, especially these 2 fungal diseases. There's really no impact, if you noticed, on spotted wilt, but on these fungal diseases there's a huge impact of rotation, and that will be important when we start looking at the disease risk of the individual varieties, because of course if you're planting a 20-point risk variety, you would need to wait until later in the planting season to reduce your risk, compared to planting a 10 or 15-point variety when you could plant earlier in the season, maybe even as early as May 1 to 10, to get that same lower risk category. just to summarize part 2 here, we've looked at these factors, some of these factors, and we know that rotation is a key factor in helping us to reduce disease risk. And all these factors are interacting with one another at any one time, so it's very difficult to look at every single scenario. But what we want to look at next is a variety with potential. How do we make sure that whatever we're doing with these other factors, we have this variety that has the yield potential that we're showing, and how do we achieve that? So in part 3, we're going to look at individual varieties and how each variety's strengths and weaknesses can be used to make sure that we maximize the yield potential of that particular variety.